Now we are discussing about the waveforms of a frequency modulated signal. Try to concentrate on this topic more because here you will get a lot of points. I can take the message signal is a sinusoidal also, but for a more clarity of understanding, I am taking a square waveform, peak amplitude varying from minus AM to plus AM. Generally, carrier frequencies are more when compared with the message. For our clarity of understanding, in each of duration of message, I am taking 2 cycles of the carrier. Not generally 2, it will be more. Just for your understanding, I am indicating its frequency is more, like I am taking 2 cycles. Now, I want to draw the FM signal. What is the frequency modulated signal, sir? In frequency modulation, let's take carrier amplitude varying from AC to minus AC. What is the FM signal, sir? The frequency modulated signal is nothing but the frequency of a carrier is varied linearly in according to amplitude variations of message is called frequency modulation. Now, in frequency modulation, the frequency of a carrier is going to be varied. So there is no change in the amplitude of a carrier. So the same AC minus AC. That is the first important point. In FM signal, there is no change in the frequency of a carrier. In FM signal, there is no change in the amplitude of a carrier before and after modulation. I can say the total power in FM signal before and after modulation is the same. Means PT is equal to PC. Where PC is the carrier power, PT is the total power, both are same because no change in the amplitude. So that's why frequency modulation is also called power efficient utilization technique. The meaning of power efficient utilization means here PC means the power taken by the carrier before modulation, PT means power taken by the carrier after modulation. Means if the carrier is taking 50 watts of power before modulation, now after frequency modulation, that 50 watts is converting into carrying our sidebands. In frequency modulation, there is no additional carrier, but a fraction of carrier will be there. Means out of 50, almost 45 to 48 watts is converted to carrying our sidebands. So that's why I called FM is power efficient utilization technique, but not AM. If you see in AM, PC will be as it is after modulation also will be there. PSB is extra adding. But here, that PC itself is majority converting into PSB. Now, let's draw the waveforms. In this duration, M of t is positive and max. M of t is positive and max means frequency also maximum. So what you will get, students, here F max you will get. Here M of t is minimum and negative. What you will get, student, here F minimum, like that. F max means what? Frequency is more. Frequency more means, students, number of cycles per second also more. Right. Frequency is less, number of cycles will be less. Frequency is more, number of cycles will be more. Frequency means number of cycles per second. Frequency is less, then means M of t is negative and less, so its frequency also less. Like you can clearly understand, as amplitude of a message is varying, the frequency also going to be varied. Understand my point or not? That is FM signal. Now follow. Now get some points here. Yeah, first point I already told. PD equal to PC, power efficient technique. Third point, 2 is power efficient. Third point is, student, follow. In FM, PT is constant. If PT is constant, sir, what is the advantage? If PT is constant, why here amplitude is constant, you can see. PT is a constant means, I can say, we can use our systems at maximum efficiency level. PT is constant, we can use our system at a maximum efficiency level. What is that meaning? Here, for example, I am designing an amplifier. I am designing an amplifier for 100 watts, for example, 100 watts. So, here PT 100 means we are designing amplifier also at 100, we are also using at 100. Then that is a better thing. But in AM, what is happening? PT is varying. If peak value is 100 and the minimum value will be somewhere around 20, like 20 to 100 is varying. Because A max to A minimum, amplitudes of AM signal varies. Means we need to design a system which has to work from 20 to 100, means we should be designed at 100, but all the time we are not using at 100. For example, if you radiate our AM signal for 10 minutes, in that one, maybe 1 minute, it will have a peak value, rest of thing will be less than that only. Means you are designing your system at 100 watt, but always you are not using it 100, students. So we are not using our systems at a maximum efficiency level. But in FM it's possible because PT is constant. Coming to the fourth point about the noise. What is the noise, sir? All unwanted thing will be noise. Here, general point, first one. Generally, noise will affect the amplitude more when compared to frequency. Generally, noise will affect the amplitude more when compared to frequency. So, generally, AM signals are more affected by noise when compared to FM. And one more point is, this is most important. If any noise is adding to the amplitude of a FM signal, that noise is called AM noise. That noise is clearly we can eliminate by using a double clipper circuit, and we know if any amplitude variations in the FM signal, that is only because of noise, because in FM amplitude is constant. But in AM, if any amplitude variations came, we cannot recognize which is because of noise, which is because of message. But in FM, if you are getting any amplitude variations like that, now you can clearly knows that these amplitude variations are came because of noise only, because in FM signal amplitude is constant. This noise itself is called AM noise, because amplitude is varying, are also called impulse noise. Important objective question. Impulse noise. What is that? Impulse noise. Because it is adding to that peak value point, so that's why it is called impulse noise. Even though what I am saying, this can be clearly clipped off. Way up to where the noise is adding, there we can keep our limiter, that is also called amplitude limiter. Of course, double-ended clipper circuit we are using, that portion will be clipped off. Even that amplitude portion is clipping off, no problem, because our information is stored in the frequency variations. But that is not possible in amplitude modulation, students, because in AM, information also stored in the amplitude, noise is also adding to amplitude, we cannot recognize which is noise or which is amplitude. So that's why the figure of merit, FOM of FM is very high when compared to AM. FM is figure of merit, which is the parameter saying about receiver capabilities against the noise. If you want that value, that point you will understand further also. Figure of merit value for FM is 3 by 2 beta square. Beta is called modulation index. That parameter will get later. Of course, beta value is 5. 5 square 25 into 3 75 by 2 37.4. If you see in AM is mu square by 2 plus mu square only. Even if you take maximum value also 1 by 3 only. See how much is the difference between figure of merit value of AM and FM. So that's why one of the important parameter of FM over the AM is noise. Coming to the next point, that is static noise. Atmosphere noise also called. What is static or atmosphere noise? Because of rain, thunderstorms, lightning, all these. This static noise effect will be severe or more up to 30 megahertz. Up to where, sir? Up to 30 megahertz it will be more. If you take AM broadcasting range, what is the AM broadcasting range, sir? 0.55 mega to 1.65 mega. Very far behind in this range. We're coming to the FM 88 mega to 108 mega, very high frequency range, far above this 30 mega. So static noise effect will be less on FM, but it will be more on AM. Now try to see the FM signal, and here itself I will also write the AM signal roughly. This will be the AM signal if you are able to see. Now if you are seeing the AM signal, you can clearly know what is the shape of the message, or you can clearly know where is the message. Message is nothing but the amplitude variations of that. Means by seeing the AM signal, we know, yes, this is our message. Our message is going like this. You can recognize its shape, but see the FM signal. Are you able to recognize its shape? Not. In what parameters message signal parameters are included in FM? Coming to the first point, in the message, coming to the first point is amplitude, students. The amplitude is stored in the maximum frequency deviation, that is, AM of the message is directly proportional to delta F. What is the delta F, sir? KF AM, KF is constant. So that's why if different messages are having same delta F, even those frequencies are different also, if their amplitudes are same. So amplitude is preserved in the maximum frequency variation. Next, what about the polarities? Whether amplitude positive or negative, this polarity you can easily know that if the frequency of a FM signal greater than FC, because of positive polarity, Fi is less than Fc because of negative polarity. Greater positive polarity, less frequency negative polarity. Next is nothing but frequency. Where is the frequency stored? Frequency is stored in the rate of deviation of delta F. So Fm is directly proportional to d by dt of delta F. Are you following my point or not? So if the rate of deviation depending upon the frequency, deviation depending upon amplitude. For your simple understanding about the frequency, suppose if the message signal, it is having time period is 1 second, student, and if this value Fc is 100k, let's take amplitude AM value 1 and 1, or for a more understand 2, let's take 2 minus 2, and a kf value is 1k you can take. Then what is happening? I am writing the Fi. Fi is nothing but Fc plus Kfam. Starting, see, here it's 0, so starting from 0. Now, what will happen? Fc plus 0 means Fc only, it is starting. Later, Kf value 1 kilo H per volt anyhow. Am value is 2, it's becoming 2. So 100 plus 2, it's becoming as 102. So later it's becoming as 102. Later one more time M of t is 0 means it is also becoming 100. Later it is becoming minus 2. So Fc minus 2 will come, so 98. And one more time it is coming to 0, so it comes to 0. 0 means 100. See, Kf value 1, Am value varying 0, 2, 0, minus 2, 0. Now, the Fi value will varies from 100 to 102, 102 to 100, 100 to 98, 98 to 100. How much this total time it is taking, or what is this rate of deviation is called, Fm. How much time it will take to make all this is nothing but 1 second, because its time period is 1. Got my point? These are about the waveforms and some of the points we discussed. Clear?